This is the second in a series of videos on permutations and combinations. And this one, where we're going to start is we're going to review the key question, right? These problems are ones in which we have a larger group. We're going to have a larger group of N and a smaller group that we're going to call R. And what we're doing is from the larger group N, we're going to choose a smaller group R. And the question is, does order matter? And if order matters, then the number of ways that we can choose this is going to be defined by permutations. And the formula is going to be NPR. And NPR is just n factorial over n minus r factorial. If we're going to, again, choose a smaller group R from a larger group N, but order doesn't matter, then that's going to be called a combination. And the formula is going to be NCR, or n factorial over r factorial over n minus r factorial. And you could either plug these in and do them by hand, or almost all calculators are going to have button NPR and NCR buttons. Let's look at an example, right? So let's say that you have a basketball tournament. And let's say in this basketball tournament you have 12 teams. And first prize gets a trophy. It's a first place trophy. And second prize gets a ribbon. And third prize doesn't get a trophy or ribbon, but they get to stand on stage and be introduced. And the question is whether, if you're at a basketball tournament, if you're one of 12 teams in a basketball tournament, and there's a first prize, a second prize, and a third prize, do you distinguish between first, second, and third place? And the answer is yes, of course. First place is ahead of second place, right? So we say order matters. And does this fit our example of N objects taken R at a time? Yeah, N is 12. That's the larger group. And from that, we're going to choose 3 people. Now, we're not choosing who wins. What we're asking is how many different ways can you come out with first, second, and third place from 12 teams? How many different outcomes are possible? Since order matters, this is called a permutation. And since it's a permutation, the formula is going to be NPR, in this case 12P3. If we look at the formula is n factorial over n minus r factorial, or 12 factorial over 9 factorial. The 12 and the 9 sort of cancel, and you get 12 times 11 times 10, or 1320. So there are 1,320 ways that first, second, and third place can come out if there are 12 teams. You can also do that on a calculator. On a calculator, you have to think about how to do this. This would be 12. And then you want P. Usually it's under a button called P or B. Sometimes you can look at the button itself. In this case, you go right there. You put enter, and it's 12, choose 3, and you get 1320. And that's an example of a permutation problem. Let's look at another problem. Let's think you're going to go on a trip, and you're going to be gone for 7 days. And you're going to wear a different pair of pants every day. So what you're going to do is you're going to choose 7 pairs of pants. And you own let's say you own 13 pairs of pants. And the question is how many different ways can you pack 7 pairs of pants if you own 13? So first, if you notice, this is also a choose problem, right? Here, N is 13, R is 7. The question is, does order matter? And there, this problem is not so clear. If you're worried about what order you would wear them, right, what day you would wear what pair of pants, then order would matter. But here we're not. We're just worrying about packing. So if you're deciding what pairs to pack, it doesn't matter what order you put them in the suitcase, so we're going to say that order doesn't matter. Now the thing to remember is whether order matters or doesn't matter is not a math problem. It's a problem of what common sense, right? It's what in the problem that you're looking at, does order matter or not? In this case, it's going to be, since order doesn't matter, it's going to be a combination. And it's going to be 13 choose 7. We're going to do that by hand. That would be 13 factorial over 6 factorial, 7 factorial. I'm just going to do this on my calculator. I go 13. I look at PRB, and I go to choose, and I'm going to choose 7. And I get 1,716 ways. In other words, there's 1,716 ways to choose 7 pairs of pants out of 13 if I don't care about what order I put them into my suitcase. And there's an example of a permutation problem and a combination problem. The key question is, does order matter? And the next video you should watch would be the next part.